Hello, this is Mr. Milani, and today we're going to begin the topic of stoichiometry. Stoichiometry, the name, is the hardest part. So you'll maybe have heard that it's fixed in your head for you. So that's the purpose of this video then, is not to really go over the numbers, but really to kind of create a map in your head so that you can know what you're doing, when, and why. Now, the nice thing about stoichiometry is that it is something that chemists use. It's something I do as I create chemicals that we use in our lab. It's something that you'll see allows us to be really kind of precise and scientific and predict and prepare, as opposed to just learning a concept and repeating a concept, or just doing it because we're told that's the right answer, that sort of thing. So this is real chemistry. And all stoichiometry is it's a way to take a known quantity of one chemical in a balanced equation, and using that known quantity, figure out all we need to know about the quantities of the other chemicals in the balanced equation. So, for instance, if we know how much of a product we want to create, we can then know how much of the reactants we need to create that product, which is stoichiometry. All right. So basically, stoichiometry is just balancing equations and mole conversions, like mole to gram, gram to mole. And most of you listening to this now have done all that already. So stoichiometry is just putting it all together into a process for a purpose. And again, once you know what you do, why you're doing each step, and when to do it, the steps themselves aren't that hard. All right, so to properly understand this, we need to remind ourselves what a balanced equation means. Here we have the Hopper process, nitrogen and hydrogen making ammonia, synthesis of ammonia. And so we balance the equation, and you got my 3-2 trick works, so it's done right away. Watch my balanced equation video if you haven't yet. Basically what this tells us is that for every 1 mole of nitrogen, we're going to need 3 moles of hydrogen to produce 2 moles of ammonia. But this also tells us that for every 3 moles of hydrogen we use, we need 1 mole of nitrogen to produce 2 moles of ammonia. And it also tells us that for every 2 moles of ammonia we make or want to make, we need 1 mole of nitrogen and 3 moles of hydrogen. So if you have a certain amount of ammonia you want to make, stoichiometry will let you figure out how much nitrogen and hydrogen you will need to make that ammonia. So again, you can be predictive, you can be scientific. So how I visualize it, I didn't really visualize it with a billy goat, but I was goofing off and saw how easy it was to add a billy goat. So I added a billy goat. But I view the balanced chemical equation as a bridge. And billy goat's going to show you it's easy to go across the bridge. You can go from one chemical to another using the balanced equation. But you can walk across a bridge in either direction, right? So the key point here, though, is that the only way we can go from one chemical to another chemical is if they are both in moles. And the reason for that is because chemicals weigh different amounts. They have different masses. And so we can't use grams. Grams of ping pong balls don't tell you how many ping pong balls you have really, so you can't use the same amount of grams of ping pong balls and bowling balls to make a molecule. You'd have to figure out, hey, I got a dozen ping pong balls and a dozen bowling balls, from which I can make a dozen ping pong bowling ball pairs or whatever. Same thing with moles. Moles is a way we can get equal amounts of molecules to react together. So we have to have everything in moles in order to go from one chemical to another. But what if they give us grams as a starting place? What if you have grams of your product that you start with? Well, you just convert grams to moles then. And then you can go from moles of your starting a compound to moles of your ending chemical. And so now I can hear some of you get confusing yourself, thinking ahead. It's always good to think, appreciate that, but don't allow yourself to be confused unnecessarily here. You can go from any one chemical to any other chemical using this same process, regardless of whether it's a product or a reactant, and the ending one is going to be a product or a reactant. It just doesn't matter. In fact, young Bill Murray is going to take this moment to tell us, Bill, what do you have to say about whether we're going forwards or backwards?
But it doesn't matter. It just doesn't matter. It just doesn't matter. I tell you, it just doesn't matter. It just doesn't matter. It just doesn't matter. It just doesn't matter.
All right. So we can go from starting chemical, reactant to reactant, or reactant to product, or we can start at the product and go to either one of the reactants. It just doesn't matter. Now, that's if we have moles. But if we start with grams, we just convert grams to moles, then we can do the mole to mole. We can have grams of any of our chemicals to start with. We just convert that to moles and then go mole to mole conversion to our ending compound. And if they ask us for how many grams of our final compound, we just convert moles to grams. So at most, we have 3 conversions, but it could be just one conversion as well. So here's just quick take here. You can go grams to moles of our starting compound. Here, let's say it's hydrogen. Once we have moles of hydrogen, we can either go to ammonia or to nitrogen. And if they want us to go grams of our ending compound, you just convert moles to grams. So long story short, here's how I visualize stoichiometry. Here's the picture I have in my head. Sometimes, many times, you start off with grams. If you have grams of your starting chemical, you have to convert it to moles. But sometimes you don't. Sometimes they give you moles of your starting chemical, in which case you don't need to do this conversion, right? But you'll always have to do this next conversion, converting from moles of your starting compound to moles of your ending compound. And then if the problem asks you how many grams of your ending compound, just convert that to moles or to grams. Moles of ending compound to grams of your ending compound. And really that's all there is to it. The next video will be some examples. We'll do some problem solving. You can see things in action. And it's just a matter of practice. You'll need a periodic table and a calculator. And other than that, practice, practice, practice. So it's easy enough. If Billy Goat can do it, you can do it.
Please hang up and try again.